Laws of exponents is what we are going to move into. So I believe that this is new for all of the 7th grade accelerated kids. I don't think any of you have covered this yet. So we are starting brand new. So laws of exponents, we are going to break this down and we're just going to focus on the product property and the quotient property. So that's all we're going to focus on for today. So we've got product and we've got quotient. All right, so if we take a look at this, when we look at algebraically, here's what it looks like. A to the m times a to the n means a to the m plus n. So basically all this says, remember, this is your base, this is your exponent, the entire thing is a power. So if you notice, we're multiplying same bases. So this base times this base, they're exactly the same. What you do is you add the exponents together to get your answer. So let's look at an example of what this will look like. So if we have x to the second times x to the third, if you notice, we're multiplying same bases. So our bases are identical. Because we're multiplying those, all we have to do is add our exponents together. So we get x to the second plus the third. So our final answer would be x to the fifth. So let's look at why this actually does work. So why this works. So x to the second times x to the third, we figured out equals x to the fifth. And here's why. X to the second is the same thing as doing x times x. We're multiplying that by x to the third, which is x times x times x. So now, if we look at this, this is the same thing as 1, 2, 3, 4, 5 x's being multiplied, which is where we get x to the fifth. So that is why it works. And it works with numbers and with variables. So it works with both cases. So let me box this out. And then I'll give you a second to copy down anything you want to copy or anything you need to catch up on. All right, so remember, multiplying same bases means add the exponents. Okay, so multiplying means add your exponents. All right, so let's look at another example. So here's another example that we can do. So we have 2m to the third times 2m to the sixth. So if we're doing this, we're going to do 2 times 2, which gives us 4, and then m to the third times m to the sixth. Because we're multiplying same bases, we add the exponents. So we get m to the ninth power. We'll try one more example. We will do 4n to the fourth times 2n to the negative third. So here we're going to multiply 4 times 2, which is going to give us 8. Here we're multiplying same bases, so we add the exponents. So it's going to be n. We have 4 plus negative 3, which gives us 1. So therefore, it's just 8n to the first power, which is the same thing as 8n, is how we would write that. Okay, now let's take a look at the quotient property. So I'm going to draw another rectangle here. We put our information inside of this. All right, so we'll stop there. So the quotient property, the algebra behind this. So in this case, if we have a to the m divided by a to the n, this is the same thing as doing a to the m minus n. So let's look at an example of what that means. If you have x to the fifth divided by x to the third, to get your answer, you're going to do x to the fifth minus 3, which is x to the second. So here, when we're dividing same bases, we subtract our exponents. So we're dividing same bases, so all we had to do was subtract the exponents from each other to get our answer. Let's see why this works. So the reason that this works, if we have x to the fifth divided by x to the third, we know that that equals x to the second. Here's why. In the numerator, we have x to the fifth. That's x times x times x times x times x. That's being divided by x to the third, which is x, times x times x. So remember, when you have something in the numerator and it matches with something in your denominator, you can simply get rid of those. So we can get rid of 1, 2, 3 of our x's. So here we're left with x times x in the numerator. We're left with nothing in the denominator, so that's like a 1. So x times x is x to the second over 1, or just x to the second. So that's why that rule works. So for this one, remember, dividing same bases means subtract the exponents. All right, I'll give you a minute. I'll highlight some stuff and I'll give you a minute to catch up with all of that. Hopefully you're able to kind of catch up with all of that stuff there. And we will take a look at some examples. So let's look at an example. I'm going to split this off so that we can have it separated. Okay, so let's look at an example for dividing same bases. So if we have 3n to the fourth over 3n to the third, basically this says 3 times whatever n is to your fourth power. This is 3 times whatever n is to your third power. So if we look at our numbers, this basically, if I cover this up, this says 3 divided by 3. So 3 divided by 3 we know is 1. So it's 1 over 1 basically. N to the fourth over n to the third tells us that we're going to do n to the fourth minus 3, which is equal to n to the first, or just n. So that means we have n to the first here. We don't need the ones, so it's just n for our final answer. Okay, we'll do one more example. So for this example, we'll do 27k to the 10th divided by 9k to the 6th. So if we look at this, 27 divided by 9 is going to give us 3. K to the 10th over k to the 6th, remember, is k to the 10th minus 6, which gives us k to the fourth power. So that would be your final answer. So that's all we're going to focus on for today, and tomorrow is just the product and quotient. So you're just going to be practicing that kind of stuff, and then we'll move on to the other ones.